presenter, the Amanda Dwi Wantira is here, isn't it? Ibu Amanda?
Yes, I'm here. Okay. Okay. May I start now?
Yes, can
Yes,
you
please,
share?
please.
Okay. Okay, I'm going to share my screen first. Okay. Yeah. Ah, okay. Um, Thank you for the opportunity given to me. First of all, I would like to introduce myself. I'm Amanda Wantira, and now I would like to present my research with Mr. Cakravastia about modeling and develop the algorithm for flexible pickup and delivery VRP with soft time window and customer selection in urban areas. Okay. Um, okay. Uh, yeah. This issue was discussed because the growth of small parcel delivery in activities in large and connected city in Indonesia continues to increase. Okay. Here we can see some of this big cities in Indonesia, such as Jakarta, Bandung, Surabaya, and Medan. And the increase in sending small parcel is due to the increasing activity of buying and selling through e-commerce platforms. Um, from 2014 till 2019, e-commerce transaction in Indonesia continue to grow, and it's predict that this trend will continue in coming years. But maybe the exception for this year because our situation. And supporting the e-commerce business, courier companies in Indonesia continue to grow also. They provide a variety service to be able to serve customer maximally, such as pickup service, even simultaneously with delivery or separately, and delivery and pickup, and then type of shipment, one-day service, or regular service, and so on. In addition, sending small parcel from e-commerce is identical with short-time delivery. The courier must be to deliver and pick up the goods once the request is received. With this various type of service and requests according to the customer need, there will be more constraint faced by courier company in being able to provide excellent service while maintaining the low operation costs. From this background, the issue to be discussed focus on the characteristics of flexible delivery and pickup, which mean the customer can get service delivery only or pickup only, or both of that service, soft time windows, and the customer selection. Okay. Previously, there were many studies that developed VRP modeling to solve routine problems with various characteristics, such as VRP with pickup delivery. Like I mentioned before, pickup, there are some type of pickup and delivery service. The pick up first and then delivery then pick up only and delivery only must be or must be. But I'm sorry, may I get 1 second to, I think there's problem with my battery.
Yeah, sure.
Okay, great. Okay, I will continue my presentation. Okay, yeah, and then beside the VRP with pickup and delivery, there are VRP with soft time window and then selective customer. There's three characteristics, in fact, appear simultaneously and cannot be separated. For that, I developed a model that is able to accommodate the problem faced by current queries. There are several studies that become references, such as from Hakani, Wang and Chen, and then Lin and Han. Okay. As mentioned earlier, the purpose of this research is build a mathematical model and develop algorithm for flexible pickup delivery (VRP) with soft time window to minimize transportation costs, considering a limited heterogeneous vehicle capacity, time window, type of service, and number of unserved customers. Okay. Okay, here I will try to explain a little about the model builder notation. Here we have a number of vehicle, the notation by M, noted by M, and then QK as denote the capacity of vehicle, and then each customer has a non-negative delivery request or DI and a non-negative pickup request or PI. Also, non-negative service time or SI, and time window or latest time window denoted by EI, and the latest time window in customer nodes denoted by LI. And a travel time is represented by TIG. Every violation of the time window, the courier will be penalized and by alpha and beta. Alpha and beta is converted from unit from the unit time. Every if the courier come earliest or late in customer nodes, and then same with alpha and beta, penalty will be imposed for unserved customer denoted by sigma. And then the objective function of the mathematical formulation is to minimize the total cost of transportation during the planning reason. And here, mathematical model objective function that I built. I have in this model has five component. The first one is fixed cost, and the second is variable cost, and then here about related with penalty, waiting, and late delay late penalty, and then the penalty charged for the unserved customer. Okay. Now, after I built the model, it is then test to see the result, and it is accordance with the desired initial concept, and there are no boundaries that are violated. For that, I try to use small data using 6 nodes and 3 vehicles to run the model. I use Lingo as a software to assistant for assistant application. And the result were obtained like this. There is no restriction or violated, and for the data use, it takes 40 second computation time. Okay, and then the experiment was carried again using larger data, and the result were verified, and the model has success in solving the problem properly and accordingly with analytic solving using the help of Lingo. We can see that the time needed to get result continue to increase as the amount data used increase and forms a polynomial graph. when the system actually has a lot of data, of course, problem solving use this method is not effective. Okay. To solve the computation time problem, then I try to develop a problem solving algorithm using LNS, adaptive large neighborhood search. Generally, the stage in problem solving using ALNS algorithm are divided into three parts. First, generating initial solution, and then improving solution, and the last is evaluating solution. The solution obtained is evaluated using the heuristic mechanism. In here, I use SI mechanism until the iteration process stop, and that is the stages in LNS algorithm developed in this study. And here the initial parameter that I use based on the previous paper that state this value is give the best solution. Okay. Okay. Next, a comparative analysis of the result obtained was analyzed analytically, and the result obtained using the LNS algorithm. For the result of small data experiment, the result obtained are good with a gap less than 10%, here 8.59%, with a much faster computation time. So the result using mathematical model and algorithm can be continued. And then testing trial were carried out using various scenarios such as change in vehicle type, number of customer point, travel time, penalty fees, and penalty fees. A total of 48 scenarios were carried out. The result obtained indicate a very good quality. The gap from the objective function is still around 10%, while the computation time to obtain result is much faster. Analysis of variance use I then using a three-factor analysis to see the effect of each characteristic and interaction between characteristics on the result obtained. Here there are a number of customer or node and vehicle and methods. Here using analytic and using algorithm. A significant level below 0.05 indicates that a significant effect on the result. Next, sensitivity analysis to see the effect of change parameters in here algorithm parameter on the quality of the solution. From the change in the algorithm parameter, we can see that the one that has a big influence on the quality of the solution is C, which means the C is the control parameter for the maximum number of points that are removed and inserted. As for the effect on computation time, maximal iteration, and then cooling factor, and then T-start have a big effect. Furthermore, to determine the best parameter that will be used in the future in a problem like this with the same characteristic, a search is carried using the Taguchi method. Change in parameter are grouped into 5 levels, and using the 6 most influencing factor are taken. The result obtained the best parameter here, and the value that we took is the highest position in every column. Finally, We try to apply this model and algorithm to real case in post office in Jakarta with office type C. There are around 1000 customer points that must be visited with 7 different vehicles and that available in that post office with 4 hours working hours. The result obtained uh, the result obtained like this and only use 6 vehicle to get the uh, lowest cost, lowest operating costs. Okay. Um, the last is the conclusion. Based on this research, the developed mathematical model can be used to solve VRP problems with limited heterogeneous vehicle characteristics, subtime window, flexible delivery and pick up, and uncertain department. And the ALNS algorithm has success in providing solution with total transportation costs that are closer to the optimal solution analytically with faster computation time, and the average gap in the objective function for 48 random scenarios was 8.5% only. Also, the computation time to complete the all scenarios that build on average is 5,000 times faster than the time required for the analytical method. And a suggestion for the further research, this research may be added to other characteristics so that it is closer to real system conditions, such as adding an uncertain road condition at any time, or maybe like what if the request from customer received when the vehicle is operating. Also, develop other methods such as insertion to determine the time to leave the vehicle from the depot, which minimize the waiting time and the light time for the vehicle to arrive customer point. That's all from me, from my presentation. If any question from audience.
Okay, thank you very much, Amanda, for that presentation. Um, any questions for Amanda? Do we have any questions for Amanda?
Yes, I am, please.
Thank you.
Okay. Good afternoon, Ibu Amanda. My name is Ristiani. I am from IPB. For my thesis, I did research about vehicle routing problem too, but the simplest one, which was optimizing the delivery route to minimize the fleet mileage and the transportation cost. First of all, I think your research is great. My question is, did you try or consider to use exact approach before the heuristic, branch and bound method? Because it's interesting for me. You got around 40 seconds, yeah, correct me
Yeah,
if I'm wrong,
yeah,
to find the global optimum solution for
yeah,
the very complex method, for the complex model
yeah.
for me. And the second one, how could you verify the model? Thank you.
Okay, yeah. Um, okay. For the first question about have I did the exact testing to this model? Yeah, I do this. I did this exact testing for this model, but not using branch and bond because there are a lot of method to test the model. I using when I built this model, I go with the simple data and the small data, and I test manually first, and then using assistant from the exact software. Uh, after that, after after this result confirm, then I can go to with heuristic methodology. That the for the first question. And the second question, sorry, the second question, could you repeat?
Okay. How could you verify the model
Okay.
before you using with the example?
Okay. Yeah. I verified my model first verified by um, what's I can I compare the not notation, but I compare the result from the analytical and from model that I built, and then I do testing sensitivity, and I do testing the variety that's a proof that this model is good and verified to apply it in real case or in another case. Yeah, I think that's from me.
Okay. Thank you. Maybe someday I can learn for you.
Okay. Yeah.
Thank you for your answer.
Yeah.
Okay, thank you, Ristiani. Any other question? Anyone with any other question for Amanda? Any other question for Amanda? Okay, maybe I should ask one that I have. Amanda, you did some analysis and recorded the computational time. I'm just wondering how this your algorithm will scale up to larger systems. Do you think you will be able to handle larger systems?
Okay. Till now, I still do the computed with the largest data around 200 data, and I still done testing for larger data than that. I think in next research or in next testing, I can do the more than this about testing the data.
Okay, thank you. Any other questions? Any other questions? Anyone? Please. Do you have any other questions? We will be rounding up shortly as we've covered all. Can I check, Putu, is there any more that we need to cover?
No, all participants that are joined already presented, Professor.
Okay. So again, thank you very much, Amanda. And I thank all our participants that presented today. It's really appreciated. And yeah, it's a nice set of presentations. And I thank you all. Hopefully, we will meet in the next OSCM conference. Thank you. And thank you as well, Putu, for your contributions as well.
Yeah. Thank you, Professor. Thank you for OSCM committee. We say thank you for all participants, also for Professor Sunmola for become the chair for this session. So after this, we will have a closing ceremony at the plenary room. So we can join the room at in the around 25 minutes after now. Thank you so much, all. See you soon.
Thank you again. Thank you. Bye-bye.
Bye-bye.